Welcome to this video on the structural mathematics and mechanics of database normalization. We will explore how data organization principles create resilient, efficient systems. Before 1970, hierarchical models were rigid and prone to failure. Codd's relational model introduced tables, using mathematics to strip away redundancies and prevent structural issues. Monolithic structures are vulnerable to data anomalies. We face update, insertion, and deletion anomalies when data dependencies aren't properly managed. Functional dependency is the engine of decomposition. It defines how one attribute, the determinant X, uniquely identifies another attribute, Y. Understanding the key hierarchy is vital. From superkeys and candidate keys to the primary key, these anchors keep our data structures sound. First normal form, or 1NF, focuses on atomicity. By eliminating repeating groups and ensuring every row is unique, we establish a clean foundation. 2NF eliminates partial dependencies. By ensuring non-prime attributes depend on the entire candidate key, we reduce redundancy effectively. 3NF targets transitive dependencies. It ensures non-prime attributes rely directly on the primary key, avoiding indirect relationships that complicate data. BCNF, or Boyce Codd, is a stricter 3NF. Here, for every non-trivial functional dependency, the determinant must be a superkey. 4NF addresses the weight of multi-valued dependencies. By separating independent multi-valued attributes, we prevent explosive data redundancy. 5NF, or Project Join Normal Form, deals with complex ternary relationships. It ensures physical structures perfectly mirror logical business constraints. This diagnostic matrix summarizes the normal forms, from atomicity in 1NF to lossless joins in 5NF, showing exactly what each stage eliminates. Engineering requires trade-offs. Denormalization is a calculated choice to reintroduce redundancy, balancing data integrity against read performance. Consider the architecture trade-offs. OLTP systems prioritize write integrity through normalization, while OLAP systems favor fast reads via denormalization. Normalization is a dial, not a rigid dogma. Master these mathematical foundations to build systems that balance resilience and performance based on your specific needs.